Again, dear students in grade 7, we are going to do together this semester 3 exam review in mathematics, but now we are going to revise the lecture of our mathematics lesson, the rules, the important rules, the most important points about our lessons. Hope you enjoy our lecture review. Thank you. The topics covered in our exams are Lesson 13, the decimal fractions, Lesson 14, which is congruent triangles 2. In this lesson, we studied the case which is two triangles are congruent by ASA, which is angle side angle. In Lesson 15, the algebraic expressions, and also you may use here the case which is SAS, the side angle side. So lesson 15, we studied the algebraic expressions, and we will revise the most important points in these lessons. Please don't forget to refer to the math review sheets of semester 3 1 and 2, and also refer to the semester 3 exam review sheets in which we solved exercises together. In our lesson, which is decimal fractions, we talked about a decimal fraction that it has denominator 10 or 100 or 1000. So to know if a fraction is decimal or not decimal, we simply look at the denominator. If we found the denominator 10 or 100 or 1000, directly we say that this fraction is a decimal fraction. A decimal number is a number that has digits with a point in between the digits. So what's the form of the decimal number? This is the form of a decimal number. The decimal number has a whole part to the left and a decimal part to the right. In between these two parts, we have the point. In the whole part, we have units which are ones, tens, hundreds, etc., 1000, 10,000. In the decimal part, we have units which are tenth or hundredth or thousandth. Now, also we learned how we write a decimal fraction as a decimal number. We have steps to write these. First, we write the numerator as it is after writing the decimal. After looking at the numerator, we write the numerator or the number in the numerator as it is. We put our finger to the right of all the digits and see the zeros in the denominator. We move our finger to the left in the numerator, and then we write zeros. We write a point. We move our finger according to the number of zeros in the denominator. Now, how we write a decimal number as a decimal fraction? First, we write the line of a fraction. To know the denominator, we count the number of digits in the decimal part. If we count one digit, then it is 10. Two digits, then it is 100. Three digits, then it is 1000, etc. To know the numerator, we write all the given decimal number as it is, but without writing the point. Now, how we write a decimal number in expanded form? The expanded form is the sum of the whole part with the decimal fractions. Each digit in the decimal part, we write it on its decimal fraction. Example, if we have the number which is 25.6, the whole part is 25, so we write 25 plus. In the decimal part, we have tenth, so we write 6 over 10. This is written in expanded form. The division technique is very important. To know the division technique, we always have a dividend divided by the divisor. We get a quotient and a remainder. Here, how we organize the dividend and the divisor to get the quotient, and down we get the remainder. Now, after making division, the quotient of a by b or a over b might be a whole natural number. It might be a decimal number when the division is exact. The remainder is equal to 0. It might be a periodic number with repetition of digits in the decimal part. It might be an irrational number that never ends. Some fractions are not decimal fractions, but we can change them into decimal fractions. If we look at a fraction that has a denominator 2, we can say that 2 can be changed into 10. How can we change 2 into 10? We multiply up and down by 5, then the fraction becomes a decimal fraction. Also, when the denominator is 4, 4 is changed into 100. How we multiply by 25 up and down. Now 5, if we multiply it by 2, we get denominator 10. 8, if we multiply it by 125, the denominator is 1000. Also 20, if we multiply it by 5, the denominator is 100. 25, if we multiply it by 4, we get a denominator 100. But be careful in a fraction when changing it to a decimal fraction. Whatever we multiply the denominator, we should multiply also the numerator. We multiply both terms of the fraction. Also 50 is changed into 100 by multiplying both terms of the fraction by 2. 125 is changed into 1000 by multiplying by 8. For example, if we take the fraction which is 3 over 5, we can say that 5 is changed into 10 multiplying 5 by 2, so we multiply 3 by 2. 3 by 2 is 6, so 6 over 10 is a decimal fraction. Another example, if we have 1 over 125. 125, we should know that it can be changed into 1000 by multiplying it by 8. So we multiply 1 by 8, so 8 over 1000 is also a decimal fraction. In our second lesson, which is congruent triangles 2, in this lesson, we've studied that two triangles are congruent if two sides and their included angle in the first triangle are equal to two sides and their included angle in the second triangle. Suppose we have two triangles. This is the first triangle, which is ABC, and another triangle, which is MNP. This is MNP. What do we mean by a side and two sides and included angle? Suppose by given we have AB is equal to MN, BC is equal to NP. What's the included angle between AB and BC? This is the included angle, which is ABC. The included angle between MN and NP is MNP. So these two triangles will be congruent by side angle side, which is the case of SAS. In our lesson, which is algebraic expressions, we talked about a numerical expression. We all know that a numerical expression in math is a sentence containing numbers and operations between the numbers, addition, subtraction, multiplication, and division. But an algebraic expression is a collection of letters called variables or unknowns and numbers organized all together using operations. So here, if I give you an example, for example, 2 plus 9 minus 3, this is a numerical expression. But if I give you 2x minus 9y minus 3, because we have letters or variables, this becomes an algebraic expression. Each term in the algebraic expression is called a monomial. So 2x is a monomial and minus 9y is also a monomial. Each one of these is called a monomial or a term. When two or more variables are multiplied together, they are written in a literal writing. Suppose we have 2 times x times y. How we write it literally? We can take away the multiplication sign and we can write it simply 2xy. This is written literally. Now, what are like terms or like monomials? These terms, they have the same variables and same powers but different coefficients. Suppose we have a squared bc cube and 10a squared bc cube. These are like terms because here we have a squared and here we have a squared. Here we have b, here we have b. Here we have c cube and here we have c cube. So these are like terms. 9x to the power 4 and 5x squared are unlike terms. Here we have a variable x and a variable x, but here the exponent is 4, the exponent is 2, because they are different exponents. So these terms are unlike. Now, how can we find the numerical value of an algebraic expression? We have an algebraic expression in which we have letters. To get the numerical value of this algebraic expression, we should replace each letter or variable or unknown by the given number or value and perform the operations. Suppose we are given this algebraic expression. X, the value of x is -1, the value of y is 2. So we replace x by -1 and y by 2. So we write 2 times x is replaced by -1 plus 3 times y is replaced by 2 and it is squared. Now 2 times -1 is -2 plus 3 times, what is 2 squared? 2 squared is 4. So 3 times 4 is 12 minus 2 plus 12, this gives us 10. Now how we multiply or multiplication of monomials? Here we have a rule. We will have a monomial multiplied by a monomial. In the first monomial we have sign, and in the second monomial we have a sign. So we multiply first the sign with the sign, then we multiply the coefficient with the coefficient, then the same variable with the same variable. This is step 3, but what do we do in step 4? We add the exponents of the similar variables. Suppose we have 3x squared times 4x to the power 4. Positive times positive gives us positive. 3 times 7 gives us 21. The variable x, it remains x, and we add exponent 2 and exponent 4. This gives us an exponent 6. To perform calculation on an algebraic expression, reducing the like terms, to reduce the like terms is to look to terms who have the same variable with the same exponent, and we perform addition and subtraction of their coefficients. Suppose we have 5ab squared. This is similar to -4ab squared and similar to plus ab squared. So the variable ab squared, the variable is ab squared, the variable is ab squared, it stays ab squared. What do we do for the coefficients? Addition and subtraction. Here the coefficient is 1. 5 plus 1 is 6, minus 4 is 2. So the coefficient is 2. And here we have -3a cubed minus 5a cubed. -3 minus 5 gives us -8, and a cubed stays the same. Addition of algebraic expressions. If we have two algebraic expressions and in between we have a plus, we write the first algebraic expression as it is, and we preserve or do not change the signs of the terms of the second algebraic expression. Then we reduce the like terms. If we have subtraction of algebraic expressions, for example, if we have two algebraic expressions a and b, and in between we have subtraction, we write the first algebraic expression as it is, but here because we have subtraction, we change all the signs of the terms of the second algebraic expression b. Thank you, my dear students. Hope you do well in your semester 3 exams. Good luck.